with the aluminum spacers, what you typically see inside most windows, you see a variation such as this. Okay, you can see it's applied right here. All right. Some companies have what they call an intercept spacer. Basically, it's a hollow piece of aluminum. It's a slightly better conductor. Here's the thing. The biggest problem and drawback that we see with the aluminum spacers, number one, from a sound standpoint, it allows sound to resonate through fairly easily. Okay. Number two, metal and glass. Let's face it, it's tough to get a very good seal. When you have two hard surfaces, the aluminum and the glass, they don't really mesh very well. So as we're talking about with expansion and contraction, especially with your vinyl products, you can imagine when you have 0 degrees outside and 65 to 70 degrees inside, there's two different temperatures coming together. When it comes to the spacer, it's basically a shearing effect with expansion and contraction and the movement. Those type of seals is what leads to the seal failures that we were talking about earlier. Okay, and if you notice, these are all perforated edges. So if you can hear this, I don't know if you can or can't, but can you hear that sound? It sounds like sand. Essentially, that's silica gel. Desiccants, it's also called. Silica gels are little sugar packets they do not eat. Okay, you see them in sneakers, leather products, even beef jerky. So what they do is they fill this hollow spacer with silica gel. Okay, put it inside the windows, seal everything on the outside, and kind of do this. Basically, what I mean by that is they say statistically within 3 to 5 years, the gases have dissipated out of your windows, but you will not notice it for maybe 15, 20 plus years, meaning you won't notice the fogging up occur. And that's simply because of the fact that those gases, the gases leak out, air gets in there carrying moisture, and the silica gel is absorbing all that moisture. So it's essentially a masking agent, okay? But the reason why companies still use this today is for one simple reason. It's very inexpensive and it's fairly strong, okay? So we use a different spacing system altogether. It's actually very, very, very exciting, very unique. It's part of our heat seal system, okay? So if you look at it, you see it's black, obviously, right? But here's the other side of it. You see the back side of it here, and I have a little cutaway. It's a very unique system in the sense that they actually use a polycarbonate base to the spacer, okay? Polycarbonate is also known as Lexan plastic. Essentially, it's like the police riot gear, their shield, that clear shield they have, is polycarbonate. It's impact-resistant plastic, okay? So that's at the base, and then they have a layer right there to add to the strength of that. A third layer of mylar, the mylar balloons. You've seen rubber balloons. They eventually deflate, where mylar does not, because mylar is a vapor barrier, where rubber balloons are actually allow for gases to escape over time. Okay, and they added a third layer, or fourth layer, pardon me, which is gray in this case, but it's also in black, as I showed you here. It's actually a rubber butyl. Rubber butyl is what they use to seal car windshields in place. Okay, so it basically consists of 4 parts. What that means to you, it creates a much tighter seal, and these gases you're paying a lot of money for, okay, right here, actually stay in your windows. We don't mask seal failure, so if something does happen, you'll see it fog up right away. But this is truly one of the biggest differences that separates our glass pack to anyone else's. Just like the Soluca is very different compared to anyone else in terms of materials, okay? So folks, what I want to do is show you a quick little experiment, if you will. May I have a couple pieces of glass of ice, please?